All right, so this is part of two course presentations. So obviously, we have the basic criteria which you will understand today for choosing a curtain wall system. And hopefully in another presentation, we will walk through the more fundamentals of the various types of curtain wall system, where we will talk about stick curtain wall system, unitized curtain wall system. So we'll go really in depth technically into that in another session. But for today's session, we will look into the high level performance criteria. So what is the role of a facade? So essentially, it needs to reduce negative external factors. So the curtain walling needs to make sure that your building is protected from heat, noise, damp, storms, rain, cold, and of course, we have abundance of sun in this region. So that is also an important factor which the curtain wall needs to protect the building from. But at the same time, these elements could also impact positively on the building. So natural use of light, effective use of the ventilation, and positive use of the sun could also be interesting formats of which the curtain wall can help benefit your building. And of course, the first thing which you see on a building is the facade. So they say the first impression is the best impression. So you always look at creating the first impression, and that's essentially a big role which the curtain wall plays. Of course, you have to deal with the forces of nature. This is a picture not very far from Dubai. This is Abu Dhabi. And we all know from the region what happens when it rains, it floods. And so we are not, I would say, insulated from the typical forces of nature, which globally many countries would experience. But the most common ones I've listed here. The first and foremost, emission and dust. So non-tested windows or doors or curtain wall will have potentially leaks like you see in the image here. And this is a common feature in most of our buildings. And this has some long-term impact, which I will explain to you in the coming days. It rains, yes, for people who live in UAE, we are always looking at new formats of rain. Today we have artificially induced rain, cloud seeding, and so on. So rains are becoming more and more common in our region, and that also has a potential impact on your window, door, and facade. So any kind of water entry into your building poses a huge risk on damaging your property inside, and also other health issues which we will see in the coming slides. So poor air tightness can lead to, of course, exfiltration of air. So you have air going from inside to outside as well. You have increased internal temperature that affects essentially your cooling loads, occupant discomfort. I mean, today, this is a big issue when you have dust coming inside. Condensation is a big issue as well. And the impact of condensation, if you are living in the region and if you've seen, especially in the last month, when the temperature is falling and your air conditioning is blasting its load inside, you will notice a lot of condensation happening, and that's again an important factor to consider, and that's essentially part of air leakage on a window, door, or facade. Unwanted heat gains and poor indoor air quality. So this is essentially an image of a mullion and transom on the spandrel, and what could essentially happen if there is if a non-tested curtain wall is used. You have exposure to outside air to come inside quite easily, and quite disturbing and leading to all these issues which I just mentioned. So the humidity issue is again part of a non-tested window, door, or curtain wall. So excess humidity combined with air conditioning causes air conditioning. So I don't know how many of you have encountered this in the last few months. As the temperature is dropping, usually you start to notice a lot of condensation, especially if your curtain wall is not tested. So condensation causes many problems. Mold growth is a big issue, and that's something which I will show you in the coming slides. Mold growth leads to poor indoor air quality, and this is especially visible when you start using drywall systems as barriers between rooms, especially in hotels and offices, because they are directly connected to your curtain wall in a building. Surface staining, corrosion of surfaces, deterioration of internal finishes, and breakdown or degradation of performance in the insulation system. So essentially, this is what we kind of took a picture of one of the projects we were investigating, a failed facade, and thanks to condensation, there's been constant staining. As you notice here, all your panels experience bimetallic corrosion, and over a period of time these panels tend to wither out and poses also potential risk to health and safety. And this is a picture from a hotel. I would not name it, but as you can see, this drywall system is connected to the mullion of a curtain wall system, which has been having condensation issues during every summer to winter transition period. And as you notice, these black spots are nothing but fungal growth. And especially during this pandemic times, you're spending more and more time inside rooms, inside buildings, and these pose a huge threat to human health. Okay, this picture is a bit exaggerated, but one would understand if this kind of fungi is constantly being exposed to us as humans, it poses a lot of risk and issue. Another problem which we also have in our region and globally, of course, is urbanization. The World Health Organization, the UN Habitat have said by 2050, 7 out of 10 people would start to move into cities. And this is something which is a global phenomenon and is witnessing even in our regions here in the Middle East. So as people start moving to city centers, the city centers get crowded, and the only way to design buildings will become high-rise buildings. So as you grow your buildings taller and taller and taller, you would have to deal with different sorts of wind pressure, wind tunneling effects, which happen in condensed spaces. And this is an issue which has been noticed even in UK recently because of these high urban movement to the city centers. The pedestrian comfort has been thrown out for a toss. People have been thrown away with winds tunneling through buildings. So you have to look out for facade or curtain walling systems which are tested for high wind pressures. I have a small example to show. Now, this is a small G+10 building in the eastern part of India, and in 2019, late May, the city was impacted by a huge cyclone, which was about 2.2 kPa of wind pressure. And although the building is a low-rise building, you can see because of the wind tunnel effect, the windows are just pulled away from the building. So it's very important that when you design a building, you have to consider for wind tunnel reports, not only for high-rise buildings, but even if a building is in a city center, densely populated, a lot of buildings around it, it's very important to go for a wind tunnel report. Today, we have a lot of options available. We can do a CFD analysis. You can do desktop assessments as well to kind of understand what is the kind of wind pressure the cladding will experience. So it's important to have that basic criteria. In the absence of the report, you have to look at the local wind speed. So traditionally in UAE, we follow 45 meter per second, that is 160 kilometer per hour. But of course, we apply the ASCE 07, the American code, which again helps us to simulate approximately what would be the wind pressure experience on different elevations of the building. So as a basic criteria, it's important to take into consideration these regulations and, if possible, the wind tunnel reports. So the topic for today: how strong are your windows, doors, and facades? So this is what we're going to be discussing today. What are the basic criteria which we need to take into consideration while choosing the right curtain wall system? So the first and foremost is water drainage. So many people have the misinterpretation that if you have a curtain wall, the water is not going to enter the area where you have the gaskets and the glass. But small amount of water is expected to penetrate through the external glazing gaskets. Therefore, the chamber around the glazing has to be drained. So in tested curtain walling systems, you would have effective drainage being executed through what we call as pressure equalization. By having these strategic holes being positioned in your mullions and transom, you're able to drain the water which seeps in through these external gaskets seamlessly. So traditionally, there are two types of drainages. One is what we call as mullion drainage, which is most commonly practiced in Europe, because the principle of the mullion drainage is any water which is accumulating on the transom, which is horizontal member, flows towards the end and then falls into the mullion drainage channel, and then the water flows down under the mullion pressure plate. So this is traditionally globally which is followed. Now, every sixth or seventh element, or let's say panel, you would have a nozzle which would then reject the water which is coming down the mullions outside. So this is how the water is expelled out of the channel and then flows down between the mullion pressure plate and cover cap. So you have the water coming in from every 6 levels, and you have the small nozzle which ejects the water out. But this is not a very popular drainage followed here in the Middle East, simply because of the workmanship. Imagine if you forget to put this nozzle, all this water is going to accumulate and it's going to remain in the curtain wall for a long period of time. So the kind of ventilation which is more popular here is field drainage, which is an alternative method of water drainage. And here each field is drained separately. So each panel, water is transferred from the mullion to the transom, and then expelled via the slots on the horizontal transom, which is hidden beneath the pressure plate and cover cap. So field drainage, again, because you're depending upon site work when it comes to the standard stick curtain wall system, field drainage is much more popular in the Middle East as you try to take on every panel one by one. So here in the field drainage, the mullion drainage channel is locked at the transom joint level. The water, as you see here, flows from the mullion to the upper surface of the transom thermal break. And each transom pressure plate has this aeration water holes. So by this principle of pressure equalization between inside and outside, water flows out through these water slots. So as you see here, you have these nicely concealed drainage slots through which water is expelled in the event of a rain or in the event of a cleaning exercise which the building experiences. And in the event of a unitized system, the concept is quite different. In a unitized system, because everything is assembled in the factory and fabricated in the factory, we have a mix of, I would say, mullion and field drainage. So here's a small animation to explain how the water is being drained out. So in a unitized system, the water not only passes through the external gaskets, but also there is a wet chamber inside the mullion for water to drain. So you have water coming through the mullion and then going to the transom just like a field drainage, but then comes back to the mullion, the vertical profile, and is then expelled out through this kind of a nozzle. So in a unitized system, because we're able to control the quality of the fabrication, you're able to do all of this in the factory in a much more nicer and cleaner fashion. So the same field drainage can be applied when you have a composite condition. So imagine you have a curtain wall and then it is interfacing with the door. You can use the same principle where the water is then drained across the mullion and to the transom and through the wider area of the door or the curtain wall profile. So water is transferred between transoms and mullions to be finally expelled and dedicated outlets. So this is a quick example of how it happens in plan, where we explain how the water moves from transom and mullions and then finally expelled outside. So it's very important that when you choose the facade aluminum curtain wall system, that how the water is drained out. So always go for a pressure equalized system and ask your supplier or your installer on the strategy for water drainage. This topic is not very common in Dubai, in the Middle East, because it doesn't rain so much. But situation is changing. As I mentioned, it's raining more than ever in these days. So you don't want your building to be exposed to risks in the event of rain. So from the water tightness, we want to come to the key checklists for aluminum curtain wall system. So the first and foremost are the most essential ones. These are air permeability, water tightness, resistance to wind loads. This is what we call as weathering performance. So these three are non-compromisable. You have to make sure that your aluminum curtain wall is being tested for these three criteria. In addition to it, dead load, knowing the weight of the glass and how the weight of the glass is transferred to the transom is important to know. How is the facade being, or the curtain wall taking on horizontal loads? For example, if you have a signage or if you have an external architectural feature which is being fixed onto your transom. Remember, your aluminum curtain wall system is a non-load bearing wall, so it can only take on its own weight. So when you're adding loads to it, it's very important to understand how these loads are getting transferred. Thermal transmittance is a very important topic, especially in our region. It's extremely hot, and we want to be smart people by reducing the energy consumption, reducing the cooling loads in the building. So it's important to understand thermal transmittance. Sound, again, as people move into cities, you have a lot of noise. So it's important that how you reduce noise into your curtain wall. What are the strategies we can follow? Fire resistance, a very important topic, a topic which is become very popular in the last few years, thanks to the unfortunate fires in the region. And resistance against impact. And we're going to look at different kinds of impacts today. So what we're going to do is we're going to walk through quickly on all these various parameters, so you get a fair bit of idea and gives you that little bit of information to help you choose the right aluminum curtain wall system. So let's look at the weathering. So weathering standards, we call it as AEV, which is air, water, and wind. So air, E is in French, so it's water in English. V is one, which is wind, and that's why we call it as AEV classification. Now, basically, we follow the European norm, which is EN 13830 for curtain walling, but other standards which are being used in the region are AMA, which is American, and CWCT standards. So these are your three go-to standards, and each standard has a different format of testing, but nevertheless, you have to understand the various criterias which we look into when we choose one facade better than another facade. So I'm going to walk you through that. For example, when you have resistance to wind load, it is calculated in kilonewton per meter square. Dead loads, again, in kilonewton per meter square. Resistance, again, impact. We measure the drop height, internal and external. I'm going to show you some videos. And depending upon the distance, you have a different classification. Air permeability, so how strong is your air infiltration? So you have starting from 150 Pascal to 300 Pascal, going up to more than 600 Pascal when the project deserves that kind of need. So you need to discuss with your curtain wall supplier on how much is the right air tightness. So traditionally in our region, 300 Pascal works very good in terms of air tightness, but it is always recommended to go up to 600 Pascal. So again, depending upon the project, the location, the environmental conditions, and so on. Water tightness, again, you have standards starting from 150 Pascal going greater than 600 Pascal. Again, here a good thumb rule is, as per the CWCT standards, 20% of your positive wind pressure, the building experiences should be the minimum water tightness of the curtain wall. For example, if you have a tower or a building which is experiencing 3 kPa wind pressure, which is 3000 Pascal, 20% of this 3000 is about 600 Pascal. So your water tightness for that should be minimum of 600 Pascal. So that's a good thumb rule to have a checklist in terms of what water tightness you should have. Airbound sound insulation, what should be the right dB? So generally you hire an acoustic specialist who comes and does a simulation and identifies the hotspots in a building. Perhaps the building is next to an airport, perhaps the building is next to a highway. So you might have noise more prone in ground floors and reduces as you go up. Maybe your building is in a city center and then you have several noise bouncing back between buildings. So that's again a value which you have to look for. Thermal transmittance, again, this is an important factor which is measured in watts per meter square Kelvin. And this is something which, again, we will see as we progress in the slide. Fire resistance, it is measured in either integrity, radiation, or integrity and insulation. So this is, again, something which is very important, certainly in buildings where there are certain zones where you want to protect your building against potential fire risk. And we will have a look at that later on in the presentation today. So these are the major factors which you have to look forward to. And this is like a good table or column to have in front of you when you are trying to choose the right aluminum curtain wall. So let's look at how a traditional testing laboratory looks. So essentially, this is a front view. You have a chamber which is completely sealed, and then you bring the curtain wall element in the front. And from the back, as you see here, this is usually accessible because people can come inside and see if there's any kind of water leakage during this kind of testing. These are some of the testing which our companies do usually in third-party laboratories. We also have our own in-house facility. So depending upon the consultant requirement, you can either choose to do it at a third-party facility or choose to do it with the curtain wall supplies in-house facility, witnessed by a third party, of course, so that you have absolute no ambiguity when you're measuring the results and so on. So when you are doing the air infiltration test, of course, there is no video for this because you can't show how air is leaking or going from outside to inside. But essentially what happens is in this chamber, we measure the air loss essentially from outside to inside, and then accordingly you will do the classification. So if your air penetration is less than 62 meter cube per hour per meter square for a wind pressure of 100 to 150 Pascal, you get A1, which is really the basic which you can achieve on any curtain wall. But preferentially A4 is a very good air permeability class to have, which is basically you have air infiltration less than 10 meter cube per hour per meter square and a wind pressure ranging from 100 to 600 Pascal. So A4 is generally a good air permeability classification to have, especially for buildings which are air conditioned, mechanically ventilated. So it's very important that you have a tight facade so that you don't, spend a lot of money on cooling loads. So anything beyond 750 Pascal is generally classified as AE 750 and so on and so forth. So the more the air pressure beyond 600, which is generally not the practice, you start to classify them as so on and so forth. So water tightness, again, this is a typical example of a chamber where you have all the water nozzles which are positioned here, and these spray water at a pressure. And this is what we call as a static water tightness, because you have a constant pressure being applied on the facade, on the curtain wall, and we measure at what pressure the curtain wall starts to leak. So essentially for a curtain wall, a good curtain wall system will have a minimum of 600 Pascal water tightness. So that's a very good water tightness to have, but today, good system companies can offer even up to 1,200 Pascal water tightness. So it is essentially a very important criteria. So depending upon your project requirement, as I told you, always look at the thumb rule. What is the wind pressure which the building is experiencing, and use the 20% thumb rule. So you obviously don't want to over design your project, but at the same time, you need to have a minimum requirement, minimum water tightness prerequisite for your project. So wind load, you saw the impact of wind load on a building. So again, here we apply excessive pressure on the panels, and then we measure how much your facade is deflecting. So if it deflects more than a certain millimeter, then the curtain wall is failing, and it gets removed from its fixation point. So you saw how the cyclone Fani removed the entire window and the curtain walling, simply because it could not take on that high wind load. So again, this resistance to wind load is defined by wind tunnel studies, by the desktop analysis, which gives you a clear idea of what should be the wind pressure the building needs to be designed for. over design could complicate the facade, make it more expensive, and under design poses a risk. So it's very important that you work on a sensible approach to ensure that there is no risk involved. So depending upon the span, so L generally is your span. So for example, if you have a declared wind load and you want to measure the wind load based on the calculations, and you want to test the curtain wall to that wind load, what we measure is basically the frontal deflection on the curtain wall should not exceed L over 200. So the span, maybe it's 4 meters or 5 meters or 3 meters, depending upon the fixation. And it should that divided by 200, or it should not exceed 15 mm, whichever is a lesser figure when measured between the points of support. I'll show you another image which will give you more clarity on this topic. So as I mentioned earlier, in the absence of a report, we follow the AAC 07 code. But again, this is a code which is defined and determined for the American market. So we always recommend to go for a wind tunnel study, or at least a desktop study, to give you more local condition perspective. So as I mentioned, this fixation element, this distance between each fixation is your L. And when we are looking at the load area, we're looking at the wind pressure attacking this mullion at these two zones. So any deflection beyond L over 200 or 15 mm on that particular wind load, then it's a failed product. However, if it does not deflect more than 15 mm, then you are good to go with that selected curtain wall. The same thing happens in transom. On the transom, what we have is trapezoidal load because of its fixation with the mullion. So when your curtain wall is being tested against wind load, you are testing both the mullion load and also the trapezoidal load on your transom. So essentially, what you want to get from the curtain wall supplier is based on the wind load, what are the inertias you get from the mullion. So this inertia moment is important to determine the depth of the mullion. So when people come to us and say, hey, we need a 160 mm depth from the edge of the glass to the back of the mullion, because that's the space we have. And we usually go back to them and say, hey, but don't go with a predefined depth, because that depth depends on the wind load, depends on these factors which we just discussed. So if you need more inertia to tackle that deflection, you need to go for a deeper profile. And in certain cases, you have to go for reinforcements. Today, we have profiles which are from 35 mm slim up to 180 mm depth, or wider profiles which are 52 by 240 and 90 by 300. So you have really depths available, but do not go with a project assuming that 160 is enough. But that will depend entirely on the wind load and the calculations. So as you see here, again in the fixation, you have two types of fixations. You have the fixation between slabs, and you have fixation which is spanning across the spandrel or the slab. So we call this left condition as flow-to-flow condition, and on the right we call this as a continuous curtain wall condition. So on the left condition, as you see here, when the pressure is acting on that span, you have this panel bending. So you don't want this Vmax to go beyond 15 mm, depending upon the span, of course. But as you see here on the continuous curtain wall, here the deflections are transferred between the two floors. So generally speaking, when you have a continuous curtain wall, you have better structural performance, and you can also save a lot on the mullion depth because you're transferring the loads between the floor levels. And also when you work with system supplier, you're able to also understand the bending moments, and by simply adjusting the fixation stack joint offset, especially on a unitized facade, you're able to further reduce the bending moment. So here, again, there is a potential to save a lot on aluminium. So it is not something which is predefined that every project will be 160. So project by project, and by discussing with us at an early stage, we could be able to advise on going for optimizing the stack joints to ensure that you have lesser aluminum used, and at the same time, you don't compromise on the depth of the profile. So it's very important, and no one project is the same. Let's look at ASTM standards, because in the Middle East, we follow a lot ASTM, especially in markets which is governed by a lot of influence from the American standards. So we have, for air infiltration, ASTM E283. In water penetration, we have ASTM E331 and 547 for static and dynamic, and uniform structurals ASTM E330. So this is something which you need to define in your specification. Otherwise, the contractor is going to just blindly give you a curtain wall which is suiting to his whims and fancies. In terms of classification, so as long as you get certain kind of design wind pressure. For example, the American standard classifies as a basic criteria for different typologies of building. For example, in the residential sector, if you have villas, they're happy with 15 PSF, which is equivalent to 0.7 kPa. And the structural test pressure is 1.5 times this value. And water resistance and is about 136 Pascal. So they are very comfortable, and they're clearly defining what should be for residential buildings. As you go to light commercial and architectural buildings, this values increase. So the American standard clearly defines, depending upon the usage of the building and the nature of the building, you have to define the performance requirements accordingly. So when you're in an early stage of a project, it's very important to discuss with your curtain wall supplier to understand what should be the specifications which you need to define, and no one project is the same. So please, my humble request is to have a look at the specifications very carefully once again, so that you don't miss out on the most important criteria which I've just mentioned over here. So how do we test traditionally our windows and doors? So remember the cyclone Fanny, which had about 2.5 kPa wind pressure. We design and test our windows and doors to what we call as ultimate design load or safety load. So you have your basic wind pressure, which let's say is 3 kPa, but we test to 1.5 times as a minimum to check if, in the case of a cyclone, if there's more augmented wind on the building, it should be able to withstand. So here is a small test, as we call as a destruction test. The product is already tested for 3 kPa, but we're trying to push the barrier and to see till what wind pressure the windows can withstand. So my colleague is shouting that it's 5,100 is 5.1 kPa, 5,300 is 5.3 kPa. Still, you can see the bending. So that's the deflection which is happening. We are here testing for destruction. So we are only trying to see till what time the window is resisting. This is 6.2 kPa, and at this time, with the pressure inside, it just disengages and falls down. So 6.2 kPa means 2.21 times the strength of the cyclone Fanny, which we just saw. So when you're choosing the window and door or a curtain wall for the project, it's very important to ask what is the wind pressure the window or door is tested for, and what is the ultimate safety factor which that product has been tested, because there's no second chance once the building is completed. So it's very important that you choose products which are tested not only for the basic wind load criteria, but also the safety factor, which is usually 1.5 times the design wind pressure. So here's an example of the ASTM test for the water tightness, but here what we follow is a dynamic testing. So in addition to the water pipes, which you see here, we bring in a bombardier engine to simulate a real life scenario. So we literally bring in a aeroplane engine to kind of simulate the rain experience on the facade. So there is not only water being applied from these nozzles over here, but also there is this dynamic wind pressure being applied onto the facade. So essentially, we are inside the chamber and we are trying to measure if there's any form of water leakage. So if you see on the video on the right, the third-party members are constantly checking, even if there's a small drop of water, that deems the test fail. So this is how we are testing water tightness. So it's very important that for projects which are high-rise, you need to consider dynamic water tests as well. And even for projects next to the sea. So if you have a project next to the sea, ensure that you have dynamic water tests done on your curtain wall, window, and door products. So that's essentially your basic air, water, and structure. Now let's look at the other formats of loads. So we're talking about dead loads and the external loads. So by dead loads, we are talking about the glass weights. Your horizontal transoms are literally holding the glass. And again, like the wind pressure, we have a certain factor beyond which your transom should not deflect. So here, the maximum deflection as per standard is L over 500 or 3 mm, whichever is lesser. So like your inertia along the x-axis, you have inertia along the y-axis. So again, there are great opportunities for architects to reduce the transom depth because the transom depth is based on the glass load and any kind of external dead load. So if you would like to have, let's say, a 180 mm mullion vertically and have a 120 mm transom, it is possible. So here again, we understand the glass configuration and calculate the inertia along the y-axis, and then we come and recommend to you, hey, as cost saving, we can reduce the transom depth, and that gives you a considerable amount of saving when it comes to the aluminum curtain wall. So these are external loads which get applied onto a building. So here we show an image of what we call as a textile architecture being incorporated onto the facade. So usually you have along the mullions and transoms, whichever is more applicable, some special anchor points, fixing brackets, which can take on these external loads. So along with the calculation for the glass, we need to calculate also for these kind of external loads. So it's very important. Other loads and other factors which we should consider. Today, architects are designing buildings with very wide floor plates, slender columns, and sometimes they get really worried because there are no columns at all positioned in several essential parts of a building, but that's how the technology has evolved. You're able to design more and more slimmer columns, but this slimmer slabs, and wider floor plates. So this poses a different, unique challenge for all of us because you have some issues to take care. So we have to consider structural tolerances, column shortening, flow-to-flow beam deflection, differential column settlement, in-plane building drift, which is again, it's important to consider when you're designing the curtain walling. Out of plane building drift, especially if you have an inclined facade, it is important to have the tolerances considered. Thermal movements, because the building, like a human being, is a thermally insulated structure. So it expands, it contracts. So you have to look at these kind of thermal movements as well. And of course, you have the fabrication and insulation tolerance, which is usually plus minus 1.5 mm. So you have to consider all these factors as well when you're choosing the curtain wall system, not only the basics, basic weathering performances, but also look at these kind of additional structural factors. So early engagement with your curtain wall supplier helps you to resolve a lot of these issues, and working closely with your structural team, the right curtain wall can be designed. Again, not one project is the same as another project, but we have to consider and treat every project in a unique fashion. Right, that takes us to the next performance factor, which is thermal transmittance. So thermal transmittance is basically, we follow EN 13947, that's the standard governing this, where we try to calculate the thermal performance of the curtain wall. And essentially, as you see here, If you use aluminium curtain wall system, aluminium is a great conductor of heat and cold. So you will need to have thermally broken curtain wall to ensure that heat from outside is not transferred inside. So when you have heat transferring from outside to inside, you start having your boundaries, your frames, which are basically having thermal bridges. So it is not alone good to have a great glass, but if you use a poor framing, it's like having a wonderful dam with leaky edges. So all the heat is going to transfer through your edges. So how do we calculate thermal insulation? So to determine the thermal feature of a curtain wall, we need to calculate its thermal transmittance. So this parameter is usually calculated as the amount of heat or cold transferred through 1 square meter of area at a temperature difference of 1 Kelvin between inside and outside. So the factor which is the unit which we use is watts per meter square Kelvin. So essentially you have the glass and you have the inside of the building, you have the frame, and this is the outside of the building. So for a window or for a curtain wall to be thermally effective, we have to consider 3 aspects. We have to consider the framing, the glass, and the spacer. So the spacer is essentially the one which divides your hermetically sealed panels of glass. So from inside to outside, you have heat or cold coming in, and from outside to inside, it is the same, which is opposite of what is just displayed here. So the U value is the U value of the window is calculated with a formula called area of glass multiplied by the U value of the glass plus area of the frame multiplied by the U value of the frame, length of this spacer multiplied by the thermal transmitter of the spacer. We have different kinds of spacers available today. You have the standard aluminum spacers, but you also have warm edge spacers which help you to improve thermal performance, divided by the area of the glass and area of the frame. So as you notice here, the area of the glass plays a very important role. Area of the frame also plays a very important role. So it is a combination of both is what's important to consider. Many of the yesteryear specification is always looking only at glass, but now more and more architects have come to the understanding that U value should be an assembly U value. So if you look at the latest codes in UAE and Saudi Arabia, they very clearly mention frame assembly U values. So this is the formula which we use. So the U value of the glass, of course, comes from the comes from the glass supplier. The U value of the frame comes from us, and then the spacer values also come from the glass processor. And this is how we calculate the U value. How do we test in reality? So we use something called a hot box method, where we have, in a sense, an area which is hot, an area which is cold. We have the specimen which needs to be tested, and then we have a fan which simulates kind of an external weather condition, and for air and temperature to transmit through this intended specimen. And we are literally measuring how much of heat, for example, in the Middle Eastern condition, and in Europe, how much of heat is retained inside. So this is a nice lab photo of how we measure the temperature or thermal transmittance along the glass and along the frames as well. So every product has to be either give you a desktop simulation or to give you a proof that this product can achieve so much of assembly U value. So traditionally, for example, with a good curtain wall supplier, you would have a list of pre-tested values with different glass performances, and you will be able to get a holistic idea of what is the overall thermal performances. Next topic is noise. And noise is a very, very misunderstood topic, and we need to understand really the basics of it. And I'm not going to go too much in detail of this, but I'm just going to give you a quick overview. So sound is basically measured in and it's a measure of frequency. So hertz is the unit, and it is usually for low frequency, we call it anywhere between 20 hertz to 160 hertz. Normal speech is 125 to 5000. High frequency opera we're talking about 1000 hertz to 20,000 hertz. The acoustic pressure is measured in Pascal with the logarithmic value. So the logarithmic value of this sound is measured in dB. So it's very difficult to identify a window which is performing good at 20 hertz or 125 hertz. So to make it more easy to have a common benchmark, we use a logarithmic value, which is measured in decibel. So the main factor for acoustic for a curtain wall is the weighted reduction of sound. So from outside to inside, how much of sound is reduced? That's what you essentially want to know. And this is supported by two terms, which is C and CTR. Let's look at what they are. So C refers to the sound of people talking, music, radio, trains passing at medium and high speed. So general noise which you hear is C. CTR is what we call as a traffic reduction or a correction factor for traffic. It refers to suburban traffic, disco music, jet aircraft flying. So all of this which makes low frequency noise. So if you are having a product which is 41 dB RW, and if your supplier comes to you and says that my product is 41 and -3, -5, this means that for medium and high frequency ranges, it is 41 -3, which is 38 dB. That is your actual sound reduction. And when you have low frequency noises, it is 41 -5, which is 36 dB. So there is two values in weighted reduction of noise. You have the C and the CTR. C is for medium and high frequency, and CTR is for low frequency noise. So this is how you interpret when somebody gives you an RW value. But you have to remember that the glass RW is not the assembly acoustic value. Now, just like the U value, your framing also makes a lot of difference. For example, when we use a highly thermally insulated product or a window or a curtain wall, you have glazing gasket, central gasket, additional gaskets. So there's a lot of mass which is being added to your frame. And this helps in improving your acoustic performance. So it is very important that when you choose acoustic, always ask for assembly acoustic performance. So we usually give the combination of the acoustic performance using the glass input. We calculate the overall assembly value for acoustics. So we have our own simulation software which is linked to our acoustic lab, where we're able to simply give the input of the acoustics, and then we're able to generate the acoustic value of the entire frame, entire assembly. Another format of noise which we talk about usually is noise between rooms. How many of you have been to a hotel and you have a room next door and you can literally listen to the noise and the conversations happening on the other side? This is what we call as flanking noise, which is represented by D and FW. So this is essentially how noise is being transferred through the wall and how the noise is being passed through the hollow mullions. So this is in plan, which you see here. So noise can pass through, of course, to the glass, can pass through the hollow mullion, can pass through the fire stop, and can pass through, of course, your drywall system or partition system, which is really separating between rooms. So we have two options for this kind of scenario. So either we can do what we call as room-to-room compartmentation, where we insulate the mullion, because hollow mullions are the ones which transmit more noise, and you protect the mullion surrounding it with nice insulation, so there is less chances of noise passing through this mullion. Another good strategy is, and this is where again early engagement with the supplier to really define the grids, when you have situations like this, to go for what we call as a split mullion. So by having this split mullion is less cost effective because you don't have to spend so much money in insulating your mullions, but by creating this natural space, you're able to not only save money, but also create a simpler detailing when it comes to construction. But of course, this should not be an afterthought. This should be thought about during the DD stage, or in fact, a little bit beyond, before. I would say schematic 50% would be a good time to relook at the grids, and whenever you have room-to-room compartmentation, really think about having this split mullions. Now this brings to the last few performance factors, fire. So when it comes to fire, there are two types of fire resistance. So one is what we call as full configuration. So when you have buildings next to each other, very closely located. Example, if you've been to Dubai Marina, buildings are so close to each other, there's hardly 3-meter space. So any fire on one building can just burst out and come and affect the building next to it. So there we have to look into what we call as a full configuration. So your podiums generally need to be fire rated completely. And then what we call is a part configuration, whereby you're talking about spandrel edge protection for fire, perimeter fire protection. That's something which we will look into it now. And the three terminologies which is very important for architects: integrity, radiation, and insulation. What does integrity mean? In the event of a fire on this facade, the glass will remain stable, but if you go close to it or any flammable material is kept next to it, that could catch fire. What is radiation? If your product is radiation certified, then for a small temperature level of 15 kilowatts per meter square, it is having no issues. But when the heat is exceeding that, you are going to have a tough time protecting combustible materials around that specimen. The most important and the most safe resistant criteria is insulation. So this is what we call as EI category. Here, for a period of the fire resistance, your glass and your framing all remains intact, and you can place any flammable material next to it. It will not have any impact. So you have two categories in fire. One is to know your basic, what we call as the F values: integrity, radiation, insulation, which is E, EW, EI, and the other one, which is the amount of time, which is the T factor, which this product can resist to. So E 60 minutes, EW 60 minutes, or EI 60 minutes. So obviously in all these three, EI 60 would be the most high performance one. So this is a quick example of how we test the fire rated door. And this was tested for EI 60 minutes. So it has the highest level of classification for an aluminium product. So this is something which is very good. Where do you use such products? Especially in server rooms, in entrances, where there is areas prone to fire. So these are areas where you have to consider using a fully fire rated door or a partition. Then we have the part assembly, and this is what we call as perimeter fire protection. So when you have the curtain wall mullion and the slab, there is a gap between these two areas, and this zone needs to be protected. Otherwise, fire could spread through the spandrel and could potentially move up the floors, or it can break the glass and jump above, and what we call as a leapfrog effect. So to test this, we have two standards. You have the EN 1364 standard, which you see on the left, and then we have the American standard is ASTM 2307. Both the cases, we are testing the performance of the curtain wall system and the spandrel to ensure that there's no fire spreading from floor to floor. So this is a very important test. So make sure, as a basic criteria for any building, if the building is above 15 meters, and that's what the code stipulates in UAE, for example, if your building is above 15 meters, make sure that your curtain wall is having fire stop or perimeter fire protection tested to either 1364 part 4 or to ASTM 2307. This ensures and gives you a peace of mind that there's no chance of fire propagation from floor to floor. Then we talk about different criteria of impact. So the most traditional forces which a facade can experience. So we are talking about people just lying on, putting their hands on the facade, or elements falling onto the facade. So it's important that you test the facade against impact. So it's very important that we do this testing, and we do this in the lab also. So depending upon the load and the height at which is dropped from, you have different classifications, like how I showed you in the table earlier in this presentation. So we are typically measuring at a particular height. We are throwing a load on the curtain wall and seeing if there is any kind of permanent deformation on the curtain wall. So during this test, we have to ensure that no parts are falling down, no rolling will occur, no breakage will occur on the glass, and all the panels remain in their position. Some deformations can happen, but that is acceptable. So the impact, internal and external. So imagine there is a healthy guy like me standing on the curtain wall and trying to push the curtain wall out. You need to measure those forces as well. So you are testing the curtain wall for internal and external impact, and those are again classified as I and E separately. So here is the different test classes. So the drop height, and depending upon the drop height, you get classification as 1, 2, 3, 4, 5, and internal I. Similarly, for external, depending upon the drop height, you have classifications E1 to E5. So here's an example of how we do the test in reality. So this is at a certain height, and then you're dropping this load. And there is definitely, as what I mentioned earlier, there should not be any kind of damage to the parts and components. You have to ensure that permanent deformations are allowed, but the components should be in place. Here is how we test the cladding component, and I'm sure our cladding suppliers will also vouch for certain tests like these. It's important, especially when you have a project where there is interfacing of glass and curtain walling, so you do the testing likewise. How do you test internal? You just simply flip the panel, and then you do the testing like how we've shown here. Okay. Then we go in for forced entry. So this is another kind of threat we have, especially in today's market, where you have villas like row houses and practically no boundaries. So there is potential threat for burglar or from forced entry. So we have a classification which is called RC, which is robber classification, and it is classifying from 1 to 6. So essentially what happens, how we test is we need to check the tools used by the robber. So if he uses some just the physical force and tries to break in, that's RC1. If he uses with some small tools, we call RC2. If he uses tools like crowbars and so on, it is RC3. RC1, RC2, and RC3 are the three major classifications which we have, and I will quickly show you a video how this is being tested. I'm running short of time, so I'm just going to wrap up very quickly. So this is just an example of how we are doing the burglar entry. So as you can see here, the crowbar is being used, and the gentleman is trying to break in, and of course he has a certain time limit. He has to do this within that time. So he's trying to open up the window using these crowbar elements, which is part of the RC3 classification. And because of the product's design, they are not able to break in. So this is similarly done in the bottom as well. They try to break in. So essentially, we're testing the product's performance at the jamb at the bottom to check if the product is being able to withstand forced entry. A few more safety solutions. The bulletproof is very important. Again, we have classification. Again, don't just use the glass values. You have to look at assembly values. So the category is starting from FB1 to FB7, and the glass category starts from BR1 to BR7. So if you have some questions on this, we can take on probably in a later session. But this is how a bulletproof curtain wall looks like, where you have specific bulletproof glass being used, which is usually 50 mm and above, and then you have special armoring plates to ensure that the bullet doesn't transfer. We also do this for the doors and for the sliding elements as well, where you have specific armoring plates which are used to protect against any bullet entry. Again, a small video of how these tests are being done in reality. This is a bulletproof glass which is being fitted onto a frame before installation. The gaskets and everything are installed as normal. This is where we choose the kind of bullet category. So we talked about FP1 to FP7. So depending upon the kilogram of gunpowder you use, you get to choose the kind of classification. So then you shoot at different zones, and then we check the overall performance, the assembly performance of the window or the door. And of course, the idea of the test is that no bullet should pass through the glass as well as through your corner joints and to the frame, and ensure that there is absolutely safety for people behind it. Again, use these kind of products when required. So we have generally these kind of products are used in embassies and government buildings and so on, and these not used for several projects. The last one is blast resistance, and I'm going to conclude with this. So essentially what happens in a blast is you have the location where or the area or the point where there is the source of the blast. So there is a distance from the face of the curtain wall, and there is a load of blast. So essentially these are the three elements which we look for. And during a blast, what happens is there's a lot of negative pressure which tries to pull the building, pull the facade out. So in a real blast environment, you ideally want a curtain wall which can withstand this negative pressure and does not let the facade break and fall inside where people are located. So we have done several tests on our products. Just to showcase a few, this was a test done in London, where you see here, this is the kind of negative pressure. We're talking about 298 kilopascal of negative pressure, which is enforced on this building. And as you see here, the glass has broken and fallen outside, which is still claimed to be passed because people inside are still protected and safe. I've got a super cool video of how the blast will be encountered from inside. So similar test condition, we kept the blast source 25 meters from the specimen, and we use 100 kg of TNT. Please ignore the music. It's quite not an appropriate music for a blast situation, but that was the marketing decision. But anyway, what I want to show you is this is the blast which happened from outside. As you can see here, the negative pressure in slow motion. The facade is literally being pulled out from its source. I'm going to show you how this looks inside from the video point of view. So let me just go back a little bit. So we had placed some cameras inside, and just want to give you a quick feeling of how you experience a blast. So as you see here, the pressure is hitting the element, and now it is trying to pull the door back out. But because the door and the glass have not shattered and fallen inside, this is considered as a pass. So where do you use such products? Projects where there's high sensitive areas, usually you use a security consultant to identify where the blast load location will be, what would be the discharge and what is the distance, and then subsequently you decide what kind of products to use. Okay, so that's to conclude. How strong is your facade? How do you choose? So I've basically listed 10 important parameters: ventilation, thermal efficiency, air water tightness, structural stability, safety. And safety, I mean, the standard safety should not be compromised, like the impact, like the fire propagation, perimeter fire protection, but project-specific safety requirements like bullet blast can also be considered. Architectural freedom, sustainability and environment, we'll talk about this maybe in some other day. Solar energy production, automation, digitalization, solar control. So there's so many factors. These are the top 10 according to me, but these are good to have on your left and the must-haves on your right. So don't compromise on ventilation, don't compromise on thermal insulation, don't compromise on weathering performance, safety, and architectural freedom. So with that, I hope I conclude today's session. And this brings us to the end of our course. Thank you so much for being a patient audience. Just a couple of slides about who we are. So we're Technal, which belong to Hydro Building System. We're here for more than 40 years. We serve more than 10 countries with over 150 authorized installers. We've completed over 2,500 projects, and we have a 95-member team here in the region with 3 warehouses. And we like to work with architects right from the concept stage to the detailed design. I insist on engaging us right from day one, so we were able to guide you and give you a lot of input when you on how to choose the right curtain wall system. Thank you for your time, and I hand over the dais back to Ali. I hope I did not overshoot my time.
Thank you very much, Arvind. Really appreciate it. As always, very insightful. And I think, you know, the presentation kind of took us through the key guidelines to selecting a system. Arvind, we're going to take a few questions, if you don't mind.
Sure.
So let's start with an anonymous attendee who, Arvind, if you look at the Q&A box, maybe you can follow with me.
Yeah.
Mm-hmm. First question is there a difference in what I should keep in mind and study in designing a facade with curtain wall and high-rise buildings versus low-rise? And I actually had a similar question in mind, in the sense that, you know, like you mentioned a lot of testing and a lot of these kind of, you know, a lot of these procedures, while for a lot of projects, it's like, you know, low-rise, mid-rise. When do we really need to get into testing and all that?
See, when it comes to using tested systems, for example, Technal, you don't have to go and test again. If you don't change the facade format, you know, the mullion depths, and if you follow exactly from the book, you don't have to test again. However, as you start modifying the system, so you have projects where you do a lot of modifications to the facade, and where you start using different elements, which is not essentially a representative of the earlier tested system, that's when you go for project-specific testing. But to answer this question in terms of for a low-rise building or high-rise building, the weathering performances will not or should not be compromised. So the curtain wall needs to be airtight, the curtain wall needs to be watertight, and needs to perform against certain structural load. So these 3 definitely non-compromisable. And of course, you have thermal performances, which are very important from an energy efficiency point of view, irrespective of a 2-story building or a 50-story building, and acoustic, depending upon the project location and so on. So I hope that answers the question, because we don't differentiate on the size of the building with the basic performances. This is definitely something which is not to be compromised. But to make it less complicated, for smaller buildings, it is always good and recommended to go for a pre-tested system, which gives the architect the peace of mind that he's using the right product fit for the project with similar environmental conditions.
Great. Okay. If anyone has any questions, please be sure to either raise your hand so we can give you the opportunity to ask, you know, by unmuting you and speaking, or you can add them to the Q&A dialog box. So, I think you answered this, but we have a question from Muhammad Arif. Mm-hmm. Says, I'm an architect from Pakistan. Just wanted to know how thermal conductivity of your Technal frame is, as aluminum frames are not good at. How do you insulate and how do you measure its performance? I think what Mohammed here is saying is that he claims that aluminum frames aren't good insulators. So how do you insulate in that case?
So it's a very good question. And as I mentioned in my slides, aluminium is a very good conductor of heat and cold. So you need to have what we call as a thermally broken profile, which separates the outside from the inside. So if I can just go back to one of the earlier slides, let me just try to run fast to that page. Yeah, so as you see here, you have your internal mullion and you have your external cover cap and pressure plate. So this particular element is what we call as polyamide. And polyamide has got a very, very low thermal conductivity compared to aluminum. So by using this thermally broken profile, and this comes as default for all of our curtain wall systems, and this helps you to reduce cooling loads, and we've got data to prove on a hot day 20 to 30% of energy bills by simply using thermally broken curtain wall. So this is how we insulate and break that thermal bridge from out to in by using this material as polyamide. And the similar applies to a window or a door system, where again I will show you here. So this is a good example of our window system, where you have the outside frame and the inside frame, and this is being split by the polyamide profile, and in some cases we use additional PU foam to further reduce the conductivity from outside to inside. So I hope this answers your question. This is essentially how we are making sure that we're using the thermally broken frames on all our products.
Excellent. Excellent. We have Shaukat Khan, whose hand is raised. Shaukat, I'm going to allow you to talk. So you can, Shaukat, please go ahead, Shaukat. We can hear you.
Yes, thank you. I have also put my question there in the chat. My question is basically regarding the blast protection. About 100 kilogram of TNT 25 meters away. My question is, I could not get any specs about glass and frame specs against this blast protection.
So it's a very good question. So for the glass which we use on a blast, it's a bilaminated glass. So you have essentially glass which is 11.5 mm outer, you have a 12 mm spacer and 11.5 mm inner. This is the glass combination we tested this for. And the aluminum frame is reinforced with steel on the mullion and transom. And we have a special patented connector which connects the mullion and the transom, which helps to withstand this kind of negative pressure. So that's the glass which we use, and we use the standard curtain wall. So we don't have a special profile for this. We use the standard curtain wall, just a little bit of quick tweaks on the accessories, and the glass is just bilaminated glass. That's it.
Okay, great. Thank you so much. We have a question from Mohammed Ataullah. So he first asked price, structure, and delivery time. I'm not sure.
Okay.
Get that.
We'll take it offline.
Yeah, we can take that offline. However, maybe you can generally touch on, I think something we talked about even earlier, the difference of generally of pricing and delivery of curtain, stick build systems and unitized systems, just generally speaking.
I mean, it's
maybe
really
not even get figures, but just like pros and cons of kind of like general.
I mean, it's all about supply and demand today. I was mentioning to you earlier, in Middle East, we have a small number of players in the unitized business, and we have a very large number of players in the stick curtain wall business. So obviously, a lot of competition on the stick curtain wall. So there's essentially price is perceived to be lesser on a stick curtain wall compared to a unitized curtain wall. But today the markets have changed. The big boys have, let's say, excess capacity. So they are being very aggressive in their pricing. And together with Technal, we have really optimized our unitized system. We got some good examples in the last 6 months where we've installed a more cost-effective unitized systems with these big boys, and we're able to somehow match the stick curtain wall system. So today, if you have a choice, especially in this region or anywhere in the world, I would advise you to consider unitized curtain wall system, because the quality of finish is absolutely perfect, because you are having a lot of factory controlled production. You're able to manufacture all these panels in a very clean environment, rather than coming to the site and then you're doing all the silicone application, you're doing all the irrespective of the system you use, it's always dependent on the workmanship at site. So today I would say you have to pay a little bit more, and I would say not more than 4 to 5%. If it's a standard curtain walling, standard facade, for a unitized compared to a standard stick curtain wall system. And that's thanks to today's situation, because the bigger boys are much more aggressive on the pricing.
And so what we also gain with Unitized is not just, as you mentioned, the quality, because it's kind of somewhat pre-assembled, but also we gain in terms of time, correct?
Oh yes, oh yes. I mean, you can put in your anchors, cast-ins too, and as your slab progresses, you're just closing your floor, your ID can move in faster. So the total ownership cost is much higher than that 5% extra which you're going to pay. And I think that's something which is phenomenal, and people really have to look at that benefit as well. If you're especially a hotel operator, you want to make sure that the facade is closed, and you want to get the hotel operating, office building, residence. If you want to get your cash flow coming in, I think you have to close the building as quickly as possible. So that's a very important point as well.
Excellent. So we're having a lot of questions. I'll try to manage as many as we can. We have about maybe 10 minutes. So question by anonymous attendee: can you explain the significance of sealants and what to consider when designing curtain wall, specifically related to structural sealant glazing? If you can quickly answer that, Arvind.
Yeah, so we have to always use compatible silicon, structural silicon sealant. So we do a lot of tests with guys like Dow Corning, Sika, Tremco, where we are always doing a lot of tests, shear tests, pull-out tests, compatibility to gaskets, compatibility to your backer rods. So we do a lot of these tests, and then we prescribe this to our metal builders to use compatible structural silicon, because these are tested and approved by Technal. So this is a very important point, and all our catalogs have references to the kind of silicon they have to use, especially when it comes to structurally glazed curtain walling systems. It's a very important point. You cannot use any silicon out in the market just because it has the same composition or chemical composition. So it has to be a compatible silicon to our system.
Okay, great. So we have Mohammed Arif Khan, who's raised his hand. Mohammed, please go ahead. Okay, Mohammed Arif Khan, are you available? All right, so we'll move on. So we have a question here by Mohammed Ataullah once again. He asks, recently and often glass have fallen from high rise in Toronto, Canada, where I live. What is the reason? So what are some reasons why glass would fall off?
Top of my head, I'm assuming this is from a project where it is structurally glazed, structurally bonded. So it could be because of poor adhesion between silicon and the frame. One of the common errors which happen in the region is if you go to Europe, for example, glass panels must be bonded onto an anodized profile only. They do not allow glass to be bonded to a powder coated profile, simply because they don't believe in the adhesion properties and the compatibility between silicon and powder coated profiles. In the region in the Middle East, what we do essentially is we have tested our glass, not our glass, but the glass whichever is being supplied in the project, and we do an addition test with powder coated surfaces. So it gives a sense of a peace of mind for people here that the product is being tested to certain level of addition. So this could be one of the reasons that the glass simply slipped from the curtain wall. It could be also because of heavy movements. You mentioned it's a high-rise building, so if the facade has not been tested for interstory drifts, interstory movements, which happens a lot in high-rise buildings, that could also potentially make the glass too pop out, or there's too much stress on the glass which pushes out, and that could be reasons why glass could fall as well. Temperature could be another reason. Different environmental conditions in Dubai, you have a lot of heat and heat, but in Toronto, I believe you have the snow, you have really cold weather conditions. So we need to know what impact that cold has got to do with the facade as well. So that could be issues which could lead to some glass breakage, glass falling down.
It could also be like, again, I'm no expert, but it could also be like the difference in temperature between the winter and the summer.
Yeah.
But also what we're experiencing a lot these days is, especially some of my friends in the Northeast in the US, they'll say like one day it's really cold, and then the next day it's almost the middle of winter and the weather is quite good. So that that difference in temperature going up and down, fluctuating a lot in a short period of time, that has an adverse effect. And
absolutely. So one thing which I didn't talk about today is thermal cycling. So that's another testing which has to be done, especially on super cold regions and even in super hot conditions like us. So thermal cycling is another factor which you also have to consider and specify based on the weather conditions of your region. So that's also very important.
Great. Okay. I think we have time for one last question. So I'll try to look for one that's a bit different. Is there a question that you want to answer, Arvind, as you're looking through these?
I mean, feel free. There's one question about a project in Pakistan. If you have a chance, please visit UBL Karachi. I think it's an award-winning project. It won the World Architectural Technal Awards last year. So yeah, if you need to visit it, please let us know. I'd be happy to kind of coordinate a visit there. It's a fantastic facade project and several other references as well in Pakistan. So feel free to reach out to us and be more than happy to kind of guide you on how to see these projects.
Great. That was a good one, an easy one.
Yeah. So the question about green building, I think this is a topic which I'm very passionate about. Absolutely. So Mispa asked, is it a possibility to create a fusion of your curtain wall with green building? Definitely, yes. I hope you mean green building regulations. Yes. By having, we can contribute literally to about 26 points on the LEED scale. So you can imagine just by a proper systematic choice of the curtain walling, you're able to get a minimum of 26 points. This includes from energy efficiency to shading to recyclability, etc., etc., etc. So yes, definitely a lot of relevance to green building and also cradle to cradle points. So yes, absolutely possible.
And by cradle to cradle points, you're not just talking about, you're actually talking also about where the materials are,
every single component.
Yes.
Every single component, the way it's sourced, it has to be sourced in a sustainable fashion. You're not supposed to use any PVC components. A whole lot of supply chain management in a sustainable fashion. So we have products from cradle to cradle bronze to cradle silver for our windows, doors, and curtain walling products. So that again helps you to achieve LEED points in your project.
All right. Well, it's 8:30 p.m. Bahrain KSA time, Kuwait. It's 9:30 in Dubai, Oman. So I will have to, first of all, thank everyone who attended this presentation. Please do follow us on Instagram. Our Instagram is AIA Middle East, pretty straightforward. Our website is aiamiddleeast.org. Please go to our website, sign up to our email list so you can get our communications. And also, please join us next week. We'll be announcing this via email and Instagram. Please wait for us for a good presentation by Equitone on fiber cement material. And Arvind, thank you very much for this presentation. As always, very informative, very entertaining. I mean, you throw some nice examples and nuances here and there, so much appreciated. And thank you to Technal by Hydro and Vicona for being sponsors of the AI Middle East, and to Equitone and Gulf Consult, our other sponsors